Okay, now we're going to do section 7.3, which is solving equations using quadratic techniques. An equation of quadratic type, I would say they're the equations that look funny. A lot of times they involve like x to the 1/2 or x to the 1/4, x to the 1/3. The easiest thing to do is write everything in descending power and then pull out any common factors. And usually if you look at the smallest degree, that's going to let you get your w. So x to the 1/4 is your smallest term, then that would be the w. All right, so let's write each expression in quadratic forms in w's if possible. So this is already in descending order. My w, I'm going to let it be x to the 3rd. So if you check, if you square both sides to see what w squared is, w squared is x to the 6th. That means when I rewrite x to the 6th is w squared, so I get 2w squared. X cubed was our w. So now this is our expression that is now in quadratic form. All right, the next one only has one term that has x. You can try letting that be a w, but w is actually going to be x to the 5th, because when I square both sides, I want that x to the 5th. So that's going to be 7w squared plus 6, which is a quadratic expression. The next one, if I let it be my smallest term, that's x cubed. If you try to square both sides, though, you're not going to get that x to the 4th, which is what we want. W squared would be x to the 6th. So this wouldn't be an expression that has w squared and w in it. So this is actually not possible. You can't write it. Right. The next one, we're going to let w equal x to the 1/3. Now, a lot of people say, well, why don't you let it be 2x to the 1/3? You don't want the whole term, you just want the x raised to the power. So when I square, this is a tough one to see at first. A square, so we know when the power of a power, we can multiply. So that's going to be x to the 2/3. Okay, so that means I have x to the 2/3, which was w squared, plus 2x to the 1/3, so w minus 4. And now that is an expression of quadratic type. All right, we didn't have any equations, we didn't have anything that equal signs. Let's see what we do when we have equations. So if x to the 4th minus 5x squared plus 4 equals 0. Now in a previous section, we actually did factor this, and that's fine. You could start it out and say x squared minus 1 and x squared minus 4 equals 0, and solve from there. That's great if you know how to do that. You could do that on your homework if you'd like to on the next reports. It doesn't matter to me. But for the sake of learning this quadratic technique, this W-substitution method, we're going to go ahead and use W's on this, and you'll see that in the answers. All right, so I'm going to let W be the smallest power, so let W equal x squared. So when I square both sides, that means W squared is x to the 4th. So I now rewrite. So I have W squared minus 5W minus a plus 4 equals 0. Okay. The x to the 4th is the W squared. The x squared is W. Now we got that. All right. Now when I factor, I'm going to have W minus 4 times W minus 1 equals 0. That means W equals 4 and W equals 1, just like normal. But my equation didn't actually ask for W's. It had nothing to do with W's. It had to do with X's. So I need to solve for X. So we back substitute. So W was equal to 4. Well, that means X squared is equal to 4. W equals 1, well, W is X squared, so X squared equals 1. And then I solve both of these. So take the square root of both sides. And I take the square root of it, plus or minus. So I get x equals plus or minus 2, and x equals plus or minus 1. Those are my 4 answers. Usually, whatever degree you have, see this was degree 4 here, that's the highest exponent, that's how many answers you're looking for. Now we talked about multiplicity before, you know, if you had 2, 2, 2, and 1 as answers. 2 would have multiples to 3, listed 3 times, but there were 4 separate answers, so still be 3. All right. Now, you guys go ahead and try the next one. The next one, you have x squared. W equals x squared. So w squared is x squared. So when you replace, you get w squared minus 29 w plus 100 equals 0. This one looks kind of hard to factor, but if you think of numbers that multiply to be 100 and add to be 29 and 25 and 4, they both need to be negative. That means w equals 25 and w equals 4. Right? We didn't ask for w, we asked for x's, so x squared equals 25 and x squared equals 4. And then the w is equal to x squared, so it's negative. When I take the square root of both sides, I get x equals plus or minus 5. And I get x equals plus or minus 4. And that's our answers. Next one, we'll let w equal x to the 1/4. So when I square both sides, I get x to the 1/4, all of that squared. So it's x to the 2/4, which is 1/10. Okay, that's exactly what I wanted, because now it's w squared minus w minus 6 equals 0. That does factor. It factors into w minus 3 times w plus 2. Notice my last terms multiply to be the negative 6. My outer and inner terms combine to be the negative w. Okay. When I set each piece equal to 0 and solve, I get w equals 3, and I get w equals negative 2. So w is x to the 1/4. So if x to the 1/4 equals 3, and x to the 1/4 equals negative 2. Okay, I need to solve both. So I have x to the 1/4. If I want to get rid of the 1/4 power, I raise everything to its reciprocal, which is 4. So raise both sides to the 4. So when I do that, I get x equals 3 to the 4th is 81. Right, now the other one, I raise to the 4th. I get x equals 16. Now one of these actually doesn't work. Now I knew back when I had w equals 3 and w equals negative 2, which one was that? The reason I knew is because when I made this substitution with x to the 1/4, I had x to the 1/4 equals negative 2. And what that means is the 4th root of some number equals negative 2. I know all about principal roots, and I know that, if I take the square root of something, I do get 2 answers, and I get plus or minus 2 or whatever the answer was. But if it already says the 4th root or the square root of something, it's assuming that that's the positive answer. There was no plus or minus in it. So I can only get a positive answer out. So I have the 4th root of x equals negative 2. That can't be true. I can't take the 4th root of a number and get negative 2 out. So that one doesn't work. So I knew right away this didn't work. Now if you didn't know that, when you went back to check, if you checked 16 in your original, you have 16 and 1/2 minus 16 and 1/4 minus 6, and you're seeing it equals 0. 16 and 1/2 is the square root of 16, which is 4. 16 and 1/4 is the 4th root of 16, which is 2. Minus 6, so I get 2 minus 6 and negative 4. That does not equal 0. So that's how you would know that that does not work. Now 81, if you check that one works out just fine. The square root of 81 is 9. The 4th root of 81 is 3. So 9 minus 3 minus 6, that doesn't equal 0. That one checks. So it is important that you check these ones, especially if they have an even root. So this is the 1/4 or the 1/2. All right, the next one looks pretty tricky. Let's try to get everything on one side of the equation. So I have x to the 1/2 minus 3x to the 1/3 minus 3x to the 1/6 plus 9, 0. When I have fractional exponents, sometimes it's hard to tell if it's in descending order. The easiest thing to do is to get common denominators for your exponents. So let's make them a common denominator of 6. That means this is x to the 2/6 minus 3x to the 2/6 minus 3x to the 1/6 plus 9 equals 0. Right, so it is in descending order. I have 3, 2, 1. Now I have 4 terms. So that's why I could go ahead and let w equal x to the smallest factor. Excuse me, still feel a little cold. So w equals x to the 1/6. That means that if I'm trying to get x to the 2/6, you would square both sides, so w squared equals x to the 2/6. And w cubed is what makes x to the 3/6. That's exactly what I want. I have w cubed minus 3w squared minus 3w plus 9 0. When you know how to solve something like this, we split the middle. So split straight down the middle. Pull out what they have in common. So they have the w squared in common, so I get w minus 3. I know I want w minus 3. So if I need w minus 3, I'm going to pull out another 3. And I know w minus 3 in common, so pull all the way to the front. I have w squared minus 3 left. Let's set it to the 0. Now set each piece equal to 0. W squared minus 3 is a factor. A lot of people think that w minus 3 times w plus 1. When you do that, you still have an inner term. You still have something that has w. So don't worry. Alright, so set each piece equal to 0. I'll get w minus 3 equals 0. W squared minus 3 equals 0. So w equals 3. W squared equals 3. So square both sides. W equals plus or minus the square root of 3. Since w is equal to 3, w is x to the 1/6. So I get x to the 1/6 equals 3 cells. Right here. So x to the 1/6 equals 3. And x to the 1/6 equals square root of 3. X to the 1/6 also equals negative square root of 3. I'm going to write that as plus or minus. I'll tell you why I repeat that. So when I try to get rid of that 1/6 power, I raise everything to the 6. X to the 1/6 to the 6 becomes x to the 1. So that's just x. 3 to the 6 is 7/29. Now when I raise both of these to the 6, a positive number to the 6th power, so a positive number 6 times, is positive. A negative number to the 6th power is also positive. So both of these are going to be positive. So that which is a number. The number is 27. So if you didn't know that, you had 3 to the 1/2 power, right? Square root of 3 raised to the 6, which is 3 to the 3 multiplied by. That's how I get this 27. All right, you can check both of those answers. They're not too hard to check. Both of them do work. So both actually are solutions. Oops.